Hello everyone, my name is The Storm, and in this video basically I'm gonna show you my latest project, which was mainly for college, but still it was creating an AI for the American checkers game, which is a pretty interesting thing to do. So yeah, the most important thing uh, when, um, I want to say is I made it on JavaScript. Um, so I'm pretty good with JavaScript. I made a couple of web games, websites, I'm all right. But when it comes to Python, I don't really, I'm not really good at it. I know machine learning is mostly done on Python with different AIs and models, but since I'm pretty good with JavaScript, as I said, and I think I might smash computer to pieces if I code on Python. I decided to make it in JavaScript. So with that aside, here comes the most important thing. The first of all, I made the checkers game, which you might be familiar with. It is a pretty interesting game. It's played on a chessboard, on a standard chessboard. Although for this project, I also made it for a 6x6 board, and it is also able to expand to a bigger board like 10x10 and even 12x12 or even small like 4x4. It's a really scalable project. And of course you play with you move on the darker squares of a chessboard, and you have a couple of things you can make. You can move either diagonal one space at a time, or you can of course capture opponent pieces by skipping over them. As you can see, you can even skip over multiple pieces, and this way you can pretty easily um, of course gain piece advantage, and even that's one of the win conditions. And the other interesting thing is the promotion. When one of your pieces go to the opposite end of where it started, it becomes a king and can move backwards, because traditionally it can pieces can only move forward, but when it promotes, can move also backwards, which is really cool. And you can skip over multiple pieces, of course, which is pretty nice in my opinion. And yeah, it's pretty interesting. Pretty interesting. Another important thing is that you have actually two win conditions. Either your player cannot move any of his pieces, or you take all of his pieces away. There's also a draw condition, which is like a stalemate in a way. If there have been like 40 moves after you captured your last piece, then it's like a draw, but I haven't made it. That aside, I think it's a pretty interesting project. You can play it for yourself, experiment with it. I will leave a link down in the description for my Git repo if you want to check the project for yourself, run it, play against my stupid AI, which is not that great. And of course, I'm gonna show you a little bit of the code. And the board is basically a class in JavaScript. As I said, all of my stuff is in JavaScript, so mainly classes. I have a board which is a class, which basically has the size that determine how big it is, and generates the pieces on the corresponding positions and make them into a one-dimensional array, which is dynamic array in a way. And we have the pieces, which are again a class, which basically has a X and a Y. It also has a color, know where which side it is on, and of course if it's a king or not. And of course there are many different methods, like the moving isn't that hard in a way, because you just move to the diagonal, so you just increase the position by 1 and -1, or -1 and -1, or +1 and +1, or -1 and +1, which are basically the four diagonals. The problem is with capturing. So for capturing, I made this stupidly long and kind of working recursive function, The idea is the piece checks on one of the four diagonals. Of course, it checks if in one of these four positions there is a piece. And if there is a piece, then it's pretty simple. You just have this long stuff of things, but the idea is you check each. We have an array to validate the position. Then we push the position to this move string in a way, and define and say which, like, the idea of the piece we will be capturing if there is piece on the square. And then we increase our hops, and in our hops it comes the interesting part where we check if the next diagonal, the next square of this diagonal is empty. If it is, we copy the move and basically make the same function again for the diagonals, since you can skip over multiples. And we use this validator here that I mentioned to kind of if, for example, if we have a king, it can move in all four directions. So we want to validate to have some way of stopping the piece of, like, we go to the right up direction and then we check the down right direction. So we are stuck in a kind of a loop. So to avoid that, we're using a validator. And of course, it's pretty complicated, but in a way it is also kind of understandable. It's not that hard to use, although I don't think it's correct. I made it fully correct, but still it works. So yeah. And as for the AI, so the AI is also really interesting. So the AI, of course, there are many different types of AI. We can use many different algorithms, but what I decided to use and what I had to use was the reinforced learning technique, which is part of machine learning. And the idea behind it is to learn similarly to humans, to trial and error. And basically, it's similar to the carrot and stick approach. If the AI does something good, you give it a positive number; something bad, a negative number. Or like you give it a cookie or a treat if it did something good, and if it did something bad, you beat it with a stick. So, but of course, that's why we use positive and negative numbers, since AI really works numbers. So yeah, I'm basically using Q-learning, which is one algorithm, one variation of how you can use this technique. And the idea is we have a table, which in my case starts as an array. We populate it, and we have like learning, like an exploration rate, and the exploration rate basically starts at 1 and goes to 0, and if it's at 1, you make completely random moves, and as it becomes closer and closer to 0, you make more and more moves which are like influenced by your Q table, which are basically, in the Q table you basically save the state of the board together with what action you took, and this pair is basically given a number using a Bellman's equation, which is this really long equation that you might want to check in the internet if you're really interested in AI. But yeah, and of course the idea is it creates a value and it puts it to the state pair, to the state action pair, and basically we go to on a given state, which is like a configuration of the board. We go to all the actions, and see which has basically the biggest value, the biggest number. We choose it. Very simple. And of course, for that, we also need to have rewards, right? So in my case, if you win, you gain 1,000 points. If you lose 1,000 points. And for each piece you capture, you gain 2 points. And for if you create a king, or capture a king, you get 5 points, which is pretty. I think it works all right. And of course, since this exploration rate starts at 1, it has to go down and down, but this is done in the training. So when it really, you play against it, basically it's already set at something like 0.1 or 0.05. That way it has like a 5% chance, or like even smaller, to make like a random move, because you always want to make random moves, because the doesn't really matter what you do. Even in games like chess or even video games, you always sometimes make some random move that might actually win you the game in the end. So it's pretty important overall. So yeah, that's about basically the AI project I made. I guess if you're again interested, you can go in my GitHub, check it out. Maybe start it so I know you are interested in it. Download it, play with it. It's really interesting. And yeah, again, if you like the video, maybe comment and like and subscribe, maybe, I don't know. And yeah, see you.